Greetings. I'm Yvonne Stapp for Science for the Public, and I welcome you to Contemporary Science Issues and Innovations. Back in August, we talked with Andrew Knoll, author of Brief History of Earth, 4 Billion Years and 8 Chapters. We ran out of time and couldn't discuss the last and very important chapter, Human Planet, the story of the Anthropocene. Dr. Knoll very kindly agreed to discuss this topic separately, and today we're delighted to welcome him back. Andrew Knoll is Harvard University's Fisher Professor of Natural History and Professor of Earth and Planetary Sciences Emeritus. He's also curator of the Paleobotanical Collections at Harvard University Herbaria. And looking beyond Earth, he's also part of the science team for NASA's Mars Exploration Rover mission. Dr. Knoll has received many awards for his research, which has established the connections between geology, chemistry, and life in Earth's history. He's also the author of 2 books for general readers, Life on a Young Planet and the must-read we are revisiting today, A Brief History of Earth. The brief history explains the partnership between the evolution of our planet and life, including natural catastrophes and subsequent developments. The final chapter describes the extraordinary human impact on our planet, which is the most important issues today. We are honored to welcome back Dr. Andrew Knoll. Thanks very much for joining us today.
Oh, my pleasure. Good to see you.
And Dr. Knoll, could we begin with just a brief recap of the book? What is that book about? And then we'll take up that very important last chapter.
Sure. I really wrote the book for 2 reasons. The first is a sense that although we're surrounded by rocks and life every moment of our lives, that most people in the modern world don't really have a good sense of how the world got here. That is the history of our planet and life. And I think on one level, it's just a fascinating story. Mm-hmm. So I tried to tell that story in accessible language. The other reason is that in understanding our planet story, we have a context for understanding the fairly dramatic changes in both Earth and life that are occurring in the 21st century because of human activities. So it's really, in a sense, you said we're going to highlight the last chapter of my book, which is about that human presence. And what I really wanted to do is, put that in the context of Earth's long history, just so we can see what an unusual moment we live in.
There are 2 things in this book that are really interesting. First of all, it shows very clearly, and most of us do not have a good background in this. It shows very clearly the relationships between geology, biology, chemistry, and these natural cycles in the history of this planet, how all of this fits together. And then in the last chapter, The Human Planet, you take up how humans changed the planet. So there were catastrophes on sort of regular cycles before. What have humans brought to the planet that has changed it?
Well, I think humans in the 21st century bring 2 things that are unprecedented. First is simply the number of us. Had you lived at the time of Caesar or at the time of Columbus, the human population wouldn't have been dramatically different between those 2 times. But now it has been growing rapidly. We are, if we haven't done so already, we're about to top 8 billion individuals. So on the one hand, there's simply a lot of humans, each influencing the world in our own small ways. The other thing that is remarkable about humans is that until industrial humans came along, the power of any animal to do something that influences the earth was sort of limited to its own muscles and physiology. And the same thing for microorganisms, which are probably much more important through time than animals. But then humans invented ways of tapping other energy sources, perhaps most dramatically fossil fuels. And that has enabled us to do, in some ways, remarkable things. I think, your great grandparents would have been astonished to know that you can get on an airplane at Boston Airport and be in London 6 hours later, but we take it for granted.
Mhm.
We heat our homes, we have all sorts of uses for energy and power, and it's hard to complain about having those things. They have changed life in many ways for the better through medicine. We in some ways live in a golden age that when you and I were kids, we all knew people who had polio. You don't see that very much except in a couple of corners of the world. And between the two of those things, not only has the human population grown immensely, but the amount of energy that each human uses has grown immensely. And put together, those wind up being a force that's capable of changing the world.
Yes. Would you say that with the beginning of agriculture, for example, this is thousands of years ago, but very advanced today, things like agriculture, have they altered the planet as well, that is very different from the way the planet was altered in the past?
Oh, immensely so. Something more than half of the Earth's surface has been
Yeah.
impacted by agriculture. And again, in some ways, that's actually great because that's what enables us to feed a hungry planet. On the other hand, every acre devoted to agriculture is an acre that no longer supports the natural biota that once lived
Right.
there. So if you actually look at the human influences over the last 100 years or so, until recently, the biggest influences were things like land use change,
Yes.
in part at least for agriculture, pollution, overexploitation of some species. Nearly all of the commercial fisheries in the world are at or beyond their capacity for sustainability. And in a sense, now global climate change is joining that pack, and all of those other things are continuing, but now in the context of a physical world that is changing at a rate that is geologically unusual.
Yes, and I understand that we altered the water cycles on the planet, all these natural cycles. Humans, having gotten dominion over the planet and its life and its forces, seem to have changed things in a way that is distinct. And that's what I want to get clear. Is it distinct from the cycles and catastrophes that came before us?
Well, in a sense, it is distinct in terms of the rate and magnitude
Uh,
of a single species. On the other hand, you know, it would be a mistake, I think, to think of industrial humans as being separate from those cycles. The fact is, we're now major participants in them. So, the rate at which humans emit CO2 into the atmosphere is of an order of 100 times greater than all the volcanoes in
yes,
the
yeah,
world. So
yeah,
we're a
yeah.
major force. We fix more nitrogen than natural life does. And those things have to have an impact. Um, and because of the various things that humans have done to sustain our own populations, there have been consequences that have led to fairly remarkable reductions in population sizes and the distribution of species, increased rates of actual extinction that are unlikely to change in the near
Yeah.
future. So in that sense, humans are like those catastrophes in the past, in that we are changing the planet at a very rapid rate. And
Okay.
in the history of our planet, extinctions, exceptional extinction intervals tend to be associated with rapid change.
Okay. Dr. Knoll, I have to ask about this because there is a lot of disinformation out there about this global climate change that people in some quarters resist this and say, well, this gets exaggerated. What's happening, people are exaggerating what's happening. This is very much like cycles in the past and so on. Could you tell us if scientists can determine absolutely whether we are making this distinct mark on the planet? Do I make myself clear there?
Yes, no,
Okay.
yeah, absolutely. And the answer is yes. I know of very few, if any, scientists who seriously question the idea that not only is the planet changing rapidly, but we are behind it. And there's a lot of ways you can actually do that, both through measurements. We
Yes.
now have places like Hawaii measurements of atmospheric CO2 over the last 70 or 80 years. It's increasing. If you look at the detailed chemistry of that CO2, it's very, very clear that the source of that is largely the burning of fossil fuels. So
Okay.
we know what's going on. We can measure the changes. We can model what climate would look like if there were not a human influence. And there's no reason to believe that we would have these exaggerated changes in the absence of human influences. So yeah, I think if scientists over the last 20 years have misinterpreted the evidence and models, it's largely that scientists tend to be conservative, and they, if anything, have underestimated the rate of change. But now we're just seeing it in front of us.
Yes. One more thing on that is that we have now methane really escaping into the atmosphere as well, which and people have pointed out, well, we've had this problem again in the past, through natural cycles, but can you clarify that? Is there a distinction of some sort that you can say, no, this is due to human action?
Well, again, we can make measurements.
Okay.
Methane's an interesting molecule, a natural gas, and
Yeah.
it on a molecule by molecule basis, it's actually a stronger greenhouse gas than carbon dioxide. The good news is there's much less of it in the atmosphere, and it has a shorter
Yeah.
lifetime in the atmosphere. If you put methane into the atmosphere, it'll be there for a couple of years and then it's gone. If you put CO2 into the atmosphere, it can be there for thousands of years. Just to then focus on the question, we can actually look at methane emissions from faulty pipes in cities. That's been done fairly recently, and it's a large number. We can look at methane that comes from the basically ice melting in areas of permafrost. That's a fairly large number. There is, in fact, a fairly large amount of methane emissions from cattle. And again, that's in some ways that's part of the agricultural system, but it is human. The size of the cattle populations is very much a function of human activities. So yeah, I think there's no question that methane emissions as well as CO2 emissions are contributing to global warming. I don't have the exact ratio offhand, but it's something like, maybe 20% or so of measured global warming over the last 50 years is attributed to methane.
Okay, and both of these are clearly attributed to the human factor. Now, our activities, our agriculture, our use of fossil fuel, and so forth. I just want to get that very clear. And I want to get these things clear, and thank you, because of the recent COP26 meeting, which has been disappointing for many people. We're looking for solution. What do we do? And could you comment on, like, how did you perceive that meeting where we're trying to get an agreement across the globe to do something about this situation, the climate change?
Yeah, now I would say at the outset that I am not an expert in policy and don't pretend to be one, but from what I've read in the aftermath of the conference, I think to give our leaders a little bit of credit, it's a step in the right direction, although the pledges that most leaders made are fairly fuzzy at this point, and one hopes for clarification of those over the next year. But I would say the best thing I can say for it is that if everything that has been promised by the COP meeting comes to fruition in a timely manner, it will slow the rate at which things are getting worse, but it's not clear to me that it will start to make things get better.
At the COP26 meeting, there were at least 100,000 people out in the streets demonstrating to urge the governments to do something, because it's going to take governmental efforts to accomplish this. It's a global issue. And on the inside of the meeting, there were very large delegations. In fact, the largest delegations, I think, were actually the fossil fuel companies. And it seemed to underscore who's got the most influence here, that we have a problem. Do you think that people can urge their governments, can be effective in pressuring governments to do something? Are governments set up like this even, right?
Yeah, I think they can. And one of the things that gives me at least a modest amount of confidence is what you just underscored in your previous statement. And that is that a lot of young people are becoming very active on this because it will affect their lives. This isn't something that's going to happen 1,000 years from now. This is something that will make a very different world by the time my kids are my age. So that's good. Governments have their benefits and their problems, and you're absolutely right that they are hearing a lot of voices. One of the things that I don't know if it gives me confidence, but I think that there's one thing that the people at fossil fuel companies know much better than most of the rest of us do. And they know that even with fracking and things like this, by the end of this century, there's not going to be a lot of petroleum
That's true. But
on mine. So if they want to be in business decades from now, they should become major investors in alternative energy sources, and at least some of them are doing that slowly but surely. And so to get at your question about what can be done, I think it is fair to say that even if we want to push everything onto governments, there's things that each of us can do as an individual. We can make wise choices in the foods that we eat. There have recently been published some very good analyses of how much CO2 equivalent is produced for a pound of protein, and beef is way out ahead of everything else. We can choose to eat foods grown locally, which takes away a significant fossil fuel cost of transportation. We can make sure that we have adequate, heating and cooling in our houses with modern types of technology, and just things like automobiles. When I think of the miles per gallon of petroleum that, you know, my parents' car had when I was a kid. It was, you know, a fifth of what our hybrid gets. And again, I suspect that within the next 15 or 20 years, most of us are going to be driving either hybrids or probably electric cars. That there's an infrastructure issue there that I think government and companies both have a role in. So there's a lot of things we can do. On the other hand, there are things that require government activity. Really, I think subsidizing and helping companies that can give us renewable fuel, renewable energy sources. I think one thing that could be important and is really growing on the horizon is there are technologies available now to actually remove CO2 from air. They are expensive at the moment, and they are not up to anything like scale to solve a global problem. But I think that's a type of technology that could, by human actions, actually roll back at least that component of global change. And I think we're going to see over the next decade both renewable energy sources and things like removal of CO2 come to the fore.
Do you know, just technically, whether it is possible to, I mean, we're going to have to do something about the CO2 because it's going to be in the atmosphere for, I don't know, thousands of years, apparently at least. And there is nothing at this moment that can address that adequately. But is it possible, do you know, just from a chemical standpoint or whatever, to delete this kind of thing? Is this possible technically?
Yes, it is possible to remove CO2 and store it in various places. And there are pilot projects in several countries now. There are thoughts on how some changes in agriculture could contribute to removing CO2 from the atmosphere. So yes, and it has to be said that, you asked earlier, and I didn't address it yet, that does nature have, is it self-correcting? That is,
can it correct this?
Would nature come back? And the answer is yes. And we've seen that throughout Earth history. It turns out that one of the big sinks for atmospheric CO2 is actually through chemical reaction with rocks.
Yes.
In the presence of water, something called chemical weathering.
Yeah.
And that turns out, interestingly, to operate at rates that depend on temperature. So as the Earth warms up, the weathering rate increases, and that actually sort of keeps the Earth in, this nice habitable zone that we're in. So the good news is that eventually the Earth will right itself. The bad news is that this will take many thousands of years. And so if you're concerned about the world that your grandchildren will live in, it's just not on the table.
Right. That's a very important point, and thank you for that, because that one is kind of hard to understand, and there have been some innovations offered to take care of the CO2 issue or the heating issue that are questionable. So we just need to know that it lasts for a long time, and we're probably talking about adaptations with very large populations, effects on agriculture and all sorts of things. One more thing, if the kinds of disruptions that we have introduced include ingredients like radiation, I should say nuclear waste, that will certainly be, I would think, affected by flooding or all of this sort of thing. The other is plastic, which is a huge problem, and other kinds of things. Can the natural systems in the earth address that? Can they overcome these kinds of problems, those particular kinds of waste? Does that sound right, clear?
Yeah, and again, the answer is similar to the one I just gave, and that is that one thing about nuclear waste is that the radioactive elements do break down into other products. So through time, that hazard will be dissipated, but the time scale for it,
Right.
again,
Yeah.
is many, many thousands of years. So if we are to have nuclear power as part of our decreasing reliance on fossil fuels, there is the commitment to storing it as safely as possible. And there's been a lot of work on that. As you may know, for the last several decades, France, for example, has gotten a majority of its energy from nuclear
Yeah.
power. So I suspect that that's going to be in the portfolio of things as we move to renewable, or at least non-fossil fuel energy. But it always comes with a high alert system that we have to be very careful. Plastics, that's an interesting problem. You're absolutely right. The rate at which plastics are being added, not only to the land surface, but the sea, is quite remarkable. We have it in our capacity to produce types of plastic that are biodegradable, and there is an increasing effort in what's sometimes called green chemistry.
Yeah.
And it is, there are numbers of people working on particularly microorganisms that are endowed with enzymes that allow them to break down plastics that have not traditionally been amenable to biological reworking. And so again, there are some very, very bright and committed people all over the world trying to address these kinds of problems, but they're big problems. And again, the time scale for their going away is relatively long.
Yes. Okay. That's very helpful to know that, all of that. So we end up with the kind of irony that human beings have this capacity to understand how to develop agriculture, how to develop energy, and so forth, and then to produce a very destructive set of conditions and impose those on the earth. Do you think that we can and will make a turnaround here? Since we have the capability, do you think that we'll get on the ball?
I think we must. So I think because of that, we will. And one has to underscore too that we can say, oh, agriculture is bad, fossil fuels are bad. But if you didn't have access to those modern systems, your life would be very different than it is now. So in some ways, the real challenge for people in developed countries like the United States is, how can we preserve our standard of living while addressing the consequences of that? And for the much larger population of people who live in the developing world, those people quite reasonably aspire to a better standard of living. And in the world as it operates now, an increased standard of living comes with increased use of fossil fuels and things like this. So for them, it's the question of, can they improve their lives in ways that don't contribute to things like global warming? And again, one has to be fair and say, if you look at all the contributions from, say, sub-Saharan Africa to global warming, it is tiny relative to the United States, Canada, Europe, China. So we don't, they are suffering the consequences, or
Of this.
our developing country friends are suffering the consequences of global change, even though they have played a limited role in generating them.
Right. So we have a moral responsibility as well there to look out for our fellow human beings who didn't do this. So,
The good news is, as you underscored, the great thing about humans is that we have this capacity
yeah.
for invention, and we have the capacity to look into the future and see what the world will be like. And as I think I actually say in my book, that we're at this kind of ghost of Christmas yet to come moment
Yeah.
from A Christmas Carol, where I think we know what will happen if we don't do something,
Mhm.
and that's sufficiently unhappy that I think and hope that good people around the world will put our individual resources and our governmental resources into changing the way we live life so that we can actually preserve our way of life.
Right. And apparently it is possible to do that if we can just make this turn and use our innovative capabilities to do something and not get discouraged. We have to really just keep the pressure on to address this. This is a very interesting chapter. Again, I want to emphasize the book is wonderful, the way that it is laid out as the earth develops and life develops, and above all, how all these systems are integrated. And it is a real contribution, and I thank you very much for that. Again, I hope that people will read this book. It is wonderful the way that you have sort of translated difficult scientific concepts, perhaps from multiple sciences, into a very readable book, the history of our planet. And I thank you very much for giving us all this information. Thanks very much for joining us today.
Thank you, Yvonne.